And now we will move on to step 4, customizing behavior by subclassing. At this moment, our class captures much of the OOP machinery in Python. It makes instances, provides behavior in methods, and even does a bit of operator overloading. Right? Yes or no? Just reply me. You just answer my question, yes? Ah, okay, fine, fine. So, the only major OOP concept it does not yet capture is customization by inheritance. In some sense, we are already doing inheritance because instances inherit methods from their classes to demonstrate the real power of object-oriented program. Though we need to define a superclass or subclass a relationship that allows us to extend our software and replace bits of inherited behavior. That's the main idea behind the OOP is, after all, by fostering a coding model based upon customization of work already done, it can be dramatically cut development time. Okay, now coding subclasses. This code means, so we have added a manager class, manager subclass, and it inherits from person. It inherits from person. Whatever code that we have written now, this code means that we are defining a new class named manager, which inherits from person class and may add customization to the superclass person. For sake of argument, let us assume that when a manager gets a rise, it receives the passed in percentage as usual, but also gets an extra bonus. That defaults to 10 percentage. For instance, if a manager's rise is specified as 10 percentage, it will get 20 percentage. For that, what I have to do, I have to add a bonus of 0.10. That's what I have done. So as this parameter is specific to customized give rise method of manager subclass. So that's the reason here you don't need to use a self dot because it is specific to this one only. Now I'll add back this to the give rise instance attribute. Now with this, now after creating a subclass and adding a customized method, if you call the same method for two instances of person and one instance of manager, irrespective of the instance type, Python runs the appropriate give rise to all three instances. This is called polymorphism in OOPS. We have discussed polymorphism in Python, but the polymorphism in OOPS is this. Irrespective of the instance type, Python runs the appropriate give rise to all three instances. This kind of behavior is called as a polymorphism. In simple terms, what give rise method does depends on what you did it or give it to the code before. This is what called as a polymorphism. Now let's call those instances and then apply this method to that, and we'll see what we are going to get. So again we use if trailing double underscore name leading double underscore is equals to main string object. Then I have created first object Charan and second object is Hari, and then third object or third instance which is of manager class. The initial two are of person class and third one is manager class. I have created that. Now let's print all three. First, for object in this thing. So create give rise. So object and give rise. So then what we got is for all three manager, for person we got 0, and for Surya we got 0, and for Hare Krishna we got this much, and for Trikala it belongs to manager class. It got a higher one based on the parameters that we have given. So now one more topic I just want to discuss is I just want you to let know the exact difference between these things. Before we enter into the next step, let us understand the subtle differences between the terms inherit, customize, extend. Extend. In general, classes can inherit, customize, or extend code in superclasses. For example, although we are focused on customization here, we can also add unique methods to manager subclass that are not present in the person superclass. So here, that's what I have done. So here I have added JD. JD, this is a new method which is specific to manager subclass. So that's the reason this is called extend. And if you do any modification to the existing method, that's called customization. If you inherit the complete class, it's called inheritation or inherit. Now let's jump into the Jupyter notebook and we'll code the same aspects in that. So now uh, as we are using more amount of concepts of whoops, the code also becoming huge and huger. So please kindly bear with me. Don't be afraid of this code. It is nothing but same code. We are copying it and then we are adding more concepts to it. That's it. You just take it simple. It's easy. So now customizing the behavior by subclassing. First task in this is make a subclass manager and add customized behavior to that subclass manager. Okay. First task, what we'll do here, this part is normal and then it also has two methods in it. In addition to that, we have added operator overloading. So this piece of code we have done in our previous step only. Now in addition to this piece of code, I want to code a subclass. A subclass. What is that subclass? Subclass manager inherits everything from main class person. However, it will have its own give rise method. This is also known as just a minute, customization. Now let me come down a bit. So let's add that piece of code, class, and then its manager subclass, and it inherits from person. So basically here inheritation part is done. Then we will customize our one of the method in the class, that is give rise. As we have discussed earlier, as we assume that manager gets a rise, just 10 percentage 10 percentage additional bonus he gets then compared to the person class. So that's what we have added here. In addition to the percentage, we have added a default bonus, that is 0.10, and then this part is done. Now with that our code ends. Now whatever we do below, these are testing. So this is all testing. I just want to test my code whether it is working properly or not. So for that, what I have done, I have created my first object, that is Madh, and then second object is Kesh. These are my two objects. Then I want to print those two objects, print Madh and Kesh, and then I just want to get the methods last name and then give rise both. So these are the attributes and methods of class, main class. So as we have written a subclass, so first we'll create the subclass object, that is wish. Wish is our subclass object, and then in addition to that, let's print all objects together. So let me execute this and then see, this is my output. The below which are class or instance objects. So these are class or instance, main person class or instance objects, and these are also related to that, whereas this is a testing subclass. Here it is, Vishnu. Vishnu is our subclass, and person, and this class name should change. So that's how we add a subclass to our function. So with that, one task is done. Then the next subtask in it is polymorphism in action. That polymorphism. So to make this acquisition of inherited behavior even more striking, we can add following code at the end of our file. Basically, this is customization. We carry the same file, but in class manager, what we have done is, in addition to the existing given arrays, we have customized this. And then let's compare each object. We have three objects, Madh, Kesh, and a manager. Total 3 objects. Now, so as we have 3 objects, and then we'll call 3 objects and we'll check pairwise of each one. If you see, pairwise of first one is 0, pairwise of second one is normal, that's 10%, but pairwise of third one is with bonus, it's 20%. So this is what we call it as a polymorphism. So this is what I am talking about, and this is nothing but polymorphism. In the added code, object is either a person or a manager. So these two classes, and Python runs the appropriate give rise automatically. Our original version in person for both objects, that is Madh and Kesh, and our customized version in manager, that is wish. And trace the method calls yourself to see how Python selects the right give rise method for each object. So this kind of behavior of Python is known as polymorphism. Then we will move on to the third subtask of step 4, that is inherit. That's the comparison between inheritation, customization, and extension. That is inherit versus customize versus extend. So in fact, classes can even be more flexible than our example implies. In general, classes can inherit, customize, or extend existing code in superclass. For example, you see this example. We will add methods using encapsulation design concept. So thus far it is remains same. So we have added subclass. Here we will look. So manager class will inherit from the person class. This is called inherited. This inheritation is known as inheritation from super or main class. And then second one is give rise uses a bonus and one additional parameter. So this type of specific implementation of method to this subclass is called customization of the inherited method, that is give rise. And if you see the third one here, finally we have added a completely new method which was not there with the person class. So that is experience method. So this is extend by making the absolutely new method in this class. So this is the difference between inherit versus customize versus experience. Here you can see all three together. So now oops ends there, and then what we have is testing all three together. So what we'll do, we will call last name give rise and then experience, because experience is completely, it is specific to the manager class only, so we can call that, and then we can see. So when I call wish dot experience and gave the two arguments inside it, then it gave me total experience of Mahavishnu is 12 years. Okay, so then